we've got this equation given to us. Sorry, I'm not writing yet. This equation given to us, and they want us to find the slope. Now, hopefully what you guys remember is that the slope can be found if you have the equation in this form, y equals mx plus b, then you know that m is your slope, and this b is your y-intercept. So we don't actually care about the y-intercept here, but it will have one. Okay, so what I want to do is I want to rearrange this equation that was given into the form of y equals mx plus b. Now, the truth is it doesn't matter if your y is on the right or the left, and it'll probably work out a little easier this time if I just leave the y on the right side. So, of course, I want the y all by itself. I'm solving for that. So what I'm going to do is I'm going to get rid of this 5. And I get 4x minus 5 equals 7y. And of course, again, I want the y by itself, so I want to get rid of the 7. We always do inverse operations. So if I'm doing 7 times y, the inverse is to divide by 7. And I need to divide that. I need to divide that side by 7 as well. Those cancel out. And this is y. So I get 4x minus 5 over 7. Now, what I can do is I can actually split this up. I can have this split up into 4x divided by 7 minus 5 divided by 7. You can split, if you have numerators, you can split that up. And each one of them will take on the same denominator. But if it's the denominator has something in it and only one numerator, you kind of have to leave it that way. So it might be some fraction stuff for you to go back and review. If you have questions about it, we can talk about it more. Now, this 5/7, this is my y-intercept. They don't ask about that, so that is what it is. But this 4x over 7, I'm just going to rewrite this as 4/7 times x. And I'll just write the rest of it. So I can take this and I can just bring it down because I'm multiplying by that value. Yeah, they got a little messy and cluttered right there. But anyways, I can bring that x down and I end up with 4/7 times x. And I do that because now I can see that this is my m. Okay, that's the slope. So the answer is B. Okay, so hopefully, that was the most common answer that we saw. But everyone who didn't answer or didn't get it right, hopefully you see where you made a mistake on that. So our class is not going to take us very long today, but we are going to be introducing the idea of transformations. All right, and this is stuff that hopefully you're already somewhat familiar with, especially when we look today at what we're doing. So anyways, I'll just jump right into it. There's not a whole lot more to say. Well, let's see, we've got some random notes right here. So if you have not signed up for Delta Math, please take care of that as soon as possible. All right, so your homework is typically going to be assigned on Delta Math. I try and limit it to somewhere between 10 and 20 minutes. So during the time that you are in class, because the class technically goes after I release you, that's a great time just to hop over to Delta Math, take care of it so you don't have any homework to worry about. It's technically almost classwork at that point. But if you don't have Delta Math, that doesn't mean that you just don't have to worry about it. That means you're going to get a 0 if you never sign up and you never actually take care of doing the work. So if you have not signed up for Delta Math and you need help with that, please stick around after class and I'll give you another reminder of this. But please take care of doing that and get signed up. All right, and there's what it says. So if you have not been able to sign up for any reason, hang out after class and we'll figure out how to do that for you. Okay, transformations. And we're going to be talking about transformations for a while, but let's just introduce the idea of what a transformation is. So geometric transformations are any sort of function that changes a figure. When I say figure, I mean a triangle. It could be a smiley face, right? It could be, it's almost a winking smiley face. Typically, of course, we're working with triangles or quadrilaterals of some kind. And so any figure that we have, sometimes even pentagons, 4, 5. Yeah, so there's a pentagon. So any figure that we have, we can transform it in some way. And we're going to talk about the very familiar kind that you guys have seen a lot. So the kind of transformations that we are focusing on are called, there's two names for it. You could call it a basic rigid transformation or just a rigid transformation. The idea of a rigid transformation is that your beginning figure, whatever it is, I'm just going to draw a circle here and a circle here. Whatever we did to get from here to here, we did not change the size or the shape of our figure. So if I kind of did all the measurements here, like what's the radius of the circle, it's going to be exactly the same over here. If it was a triangle and I ended up with this triangle right here, whatever we did, this distance x will be the same over here. This distance y will be the same. Not only are the side lengths going to be the same, but this angle right here is going to be the same as this angle. So we're not changing the figure in any of its measurements by doing any of these transformations, but we are changing how it looks. And these are ones you're already familiar with. We have reflections, rotations, and translations. Okay, and you can already imagine what those look like. We're going to focus today on translations. These are kind of the most straightforward, simplest, even if the name itself doesn't immediately come to mind what that is. When you see what it is, it's going to make sense. So reflections and rotations, you can already imagine what that would look like. If I gave you a triangle right here and I told you to reflect it, you could probably do that. If I told you to rotate it, you could probably imagine in your head what that looks like. So luckily, these are very already kind of intuitive ideas. Okay, so before we jump into the translation specifically and anything else, we do need to talk kind of a general thing about transformations is that we have what are called images and pre-images. Maybe I should have flipped the order, called it pre-images and images, because we start with a pre-image. So anytime a transformation is performed, you have to start with a pre-image. And that's the original geometric figure. And it can be any shape, it could be even like a picture if you wanted it to be. But typically, like I said, we're working with some kind of a polygon. All right, so the pre-image right here, all of these show the pre-image. So this is kind of a lightning bolt. That's a pre-image. And this is a triangle that's a pre-image. And this kind of darker green triangle here is the pre-image. So we take that pre-image and we do some kind of a transformation to it. And after the transformation has been performed, you end up with the image. So we did this, we took this lightning bolt, looks like we did some kind of a combination of things here, and we ended up with an image and so on here. So you can probably tell yourself what those transformations were in some cases. Now this is another important thing. Every one of these images, if you notice, here's an image, it's this lightning bolt on the right, this triangle on the left, this triangle on the bottom right, they all use the same notation, which has this prime notation. Now it's just a little apostrophe, but we call it prime. So A got transformed and it ended up over here at A prime. C started here, it got transformed and it ended up at C prime. So anyways, here's B got transformed, and of course now that thing popped up, but B prime is down at the bottom. So these transformed and ended up at those new locations. And this is helpful because we can see how our transformations are going to work. We're going to transform each point. So this right here, I'll go ahead and show you, this is a translation where it's just a slide, and we're going to focus on that in a second. But I did the same transformation to every point. So I went down and to the right, down and to the right, down and to the right. And I did the exact same thing for all 3 points. I know it got a little bit cluttered there, so I'll clear it up again. But look out for that notation. Another thing that you'll sometimes see is dashed lines. All right, so what that means is if I drew a triangle here, and then I translated it over to here, sometimes, of course, we'll have, like, if this is A, I might call it A prime when I'm done, but I might also draw this with dashed lines. You won't always see it that way, and these 3 examples down at the bottom, they don't show that. but sometimes they are shown with dashed lines. All right, I think that's enough about that. So let's talk about translation specifically. So a translation, sometimes called a slide, is when a geometric figure is moved up, down, left, right, or some combination therein, without changing the orientation of the figure. So if I look at the pre-image and image of both of these examples down at the bottom, you can see that it's basically a copy and paste, right? Like you can do on the computer. So it's like I copied one triangle and I pasted it somewhere else and it didn't do anything else to the figure. So that is the main idea. The pre-image and image will look exactly the same, but will be in different locations. Okay, now notice here they give us this. So that line right there is called a vector. And it's important to just know that term. A vector is something that tells us both the distance and direction. So I'll just write that down, distance and direction. And of course, we're going to look at it on the graph in a second, but this is kind of telling us to go down and to the right. Now, we do split it up, and I already talked about this to some degree, but we do split it up into horizontal and vertical movements. So with this example on the right, it kind of shows a little better. It's telling us to go 5 to the right, 5 inches, and then 3 inches up. And we do that with every point. So 5 inches to the right, 3 inches up. And we want to split it into those two components. So it doesn't help us much to say slide, if I said this was 6 inches, slide 6 inches down and to the right a bit, it's more helpful to say go completely straight up 3 inches and then directly to the right 5 inches. And we can follow those instructions a little bit better, if that makes sense. But okay, let's do this now. Okay, so the next thing to think about is we're going to be looking at these problems while they're on a graph. So the last two examples that I gave you, you didn't have a graph underneath it. There could have had one. We could have drawn one, but there wasn't one there. So anyways, if we're looking at this, you can see the graph underneath. And let's see, these are pretty simple to do as far as it goes. Some of these get more complicated, you can imagine. So here's kind of the main thing I want you to keep in mind. Every single point. So I'm going to start at point C. This is the one that they show us, and it ends at C prime. So I'll make that bigger and bolder so you can see where I'm drawing those 2 points. Okay, so if I start at C and I go to C prime, it's not just go left 4 and go up 5. That is one way of saying it. Go left 4 and up 5, and I wrote that right here. But we also want to translate that into coordinate language. And what that really means is I'm going to go -4 in the x direction. Remember, your x is telling you whether you're going left or right. And so if I go to the left, that's negative. If I go to the right, that's positive. It's just like a number line as you're counting. Okay, so I'm going left, so that's telling me to go -4. And then when I move to the vertical, I've got positive is going up and negative is going down. So since I'm going up, that's telling me to go +5 in the y direction. All right, it's going to be important to keep in mind that we're talking about coordinates here that move in positive and negative directions. All right, and again, nothing overly complicated today, but we are going to talk more about the coordinates. And when we move to other transformations, then it might be really helpful to be already drilling this idea into your mind so it makes more sense. Okay, we are going to focus more on the specific coordinates tomorrow. So right now we can see that this point C is at -2, -2. And then when we translate it, it ends up at -6, +3. All right, that's all well and good, but we're going to focus on those specific coordinates more tomorrow. Today, it's just let's get the idea of the translation down. Okay, so I'm going to come back to this at the very end, but this is your homework where it's translations, and is the name of the assignment. Make sure to get signed up for Delta Math. Remember, you're not prevented from having to do the work just because you don't have a Delta Math account. That means you need to get one. And I will come back to that. But let me, before you guys leave, let's just look at Delta Math. It's not wanting to come up, so I'll reload it. Huh. Let me just try. My internet's been acting a little goofy, but it looks like it's working now. Okay, so we're gonna look at this assignment down here. No, not construction, sorry, we're past that. We're at transformations. All right, and we're just gonna do, in your homework, it already has these assigned for you. I just wanna show you what this looks like. So it says translate the figure 3 units right and 1 unit up. So this right here, it says draw a vector from the origin 3 units right and 1 unit up. Right now, if I tried to do anything here, there's nothing I could do. Well, I could draw something, but it's not gonna work. It says draw from the origin, and the origin is 0, 0. So if you ever hear that term, oh, no worries if you had some technical difficulties. You're good. So if you ever see the term origin, it's referring to 0, 0. So I'm going to go 3 units right, 1 unit up. So this is telling me go +3 in the x direction, +1 in the y direction. And once I do that, it's going to say, just move on to the next instruction. Move the tail of the vector to each vertex of the figure. So here's kind of the point. So here's the tail of it. And this gets a little bit finicky. So it'll take me a few times trying to grab this. There it is. So now I can take this and I can drag it around, and I want to make sure it ends up in the right spot. So I will put it on that point right there. And then it's going to give me another vector that I can drag around. Again, I have to hope for the best. There it is. So I can drag it to right there. And I had to do this one last time. And once I do that, I'm done. So it's basically showing very clearly that we have to translate each point. And I'm going to submit the answer. And it gives this little sort of animation of that happening. And so that's pretty cool. So again, I'm imagining that most people aren't going to have too much trouble with this idea. So let me show you the other part of your homework. If you need to see more of that, we can come back to it. So the other thing that you're going to have to do is basically just be given a figure and translate the figure 1 unit right, 5 units up. Now it's going to be different every single time, but for every single one of these, I don't have a vector that I'm going to create and copy. So I just want to count this out myself. I'm going to take this coordinate, I'm going to go right 1 and 5 units up. So there's right 1, 1, 2, 3, 4, 5. I'm going to put a point right there. And luckily I can just kind of leave that point. This one's going to go right 1, 1, 2, 3, 4, 5. Okay. I'll just come to this point. It doesn't matter the order you go in, luckily. Right 1, 1, 2, 3, 4, 5. And lastly, this one right here. So I'm going to go right 1, and then 1, 2, 3, 4, 5. And there it is. So that looks complete to me. As soon as you have the maximum number of points, which is 4, it's going to stop giving you the option to draw stuff. So I will submit my answer, and that's it. And it still gives me that same animation. It almost looks 3-dimensional when we do it this way. So there we go. That's the basic idea of your homework. Let me go back to the presentation. Okay, so if you missed the attendance check earlier, you can confirm that you're here now. But anyways, make sure you're doing that homework. You have plenty of time left in class to get that done. If you have any questions, stick around. But besides that, you can have a wonderful day, and I will see you tomorrow.